Welcome to CleanTitans. Today, we're diving deep into the critical area of industrial heat decarbonization with a true innovator. We're joined by James Macnaghten, CEO of Caldera Heat Batteries. Welcome, James.
Ali, thank you, and delighted to be on CleanTitans.
James, your extensive background in thermal energy storage and thermodynamics is truly impressive. Could you share a bit about your journey and what sparked your passion for this field?
By all means. So I studied mechanical engineering as a student. I was at Cambridge University, and I then went off into a world of, I would say, entrepreneur, setting up a number of companies. And then in late 2000s, I got involved with a business where we were looking to store electricity by converting it into heat and cold, and then converting it back from heat and cold back to electricity. It's got a name that's a bit of a mouthful called pumped heat electricity storage, which no one needs to remember. But I spent 8 years as the CEO of a company developing that. And when we were starting, lithium-ion batteries were more than $1,000 a kilowatt hour, and there were no obvious ways of storing electricity at scale, apart from pumping water up a hill, which was pumped hydro.
Right. It's important to be able to store energy even now for much longer durations, right?
Absolutely correct. But many of the things that I believed then, I no longer believe are true now. Some technologies have made just the most amazing progress, and other technologies that looked really promising have, to my mind, have failed to deliver. So it's a very, very different world than 15, 16 years ago. And to my mind, some of the big battles have been won, which is why it's so exciting.
Right. The price of some technologies has just plummeted, and that changes the dynamics.
Absolutely. So the big wins have been in solar PV and in wind, and I would say particularly in solar PV. And then following along from that, we're seeing electric batteries, electrification of transport. And always one of my frustrations is I actually think the hard battles have been won. It's now building on that. And we're looking to build on that progress. But to me, none of this would be possible if you hadn't got cheap forms of renewable generation.
Caldera's thermal storage boiler is revolutionizing industrial heat. Can you explain the core technology and how it helps companies decarbonize?
Absolutely. So I'd like to sort of set the scene. I normally tell people half of all the world's carbon emissions come from heat, and half of that is from industrial heat. Now, when you go into industry, and industry just uses the most enormous amounts of energy often. Heat is not, you get heat used at different temperatures, and there's some heat used at very high temperatures in blast furnaces or for cement making. And then you've got a lot of heat used in the sort of medium temperature range, maybe for food production. And then there's an awful lot of low temperature heat used for things like space heating. And the bit we're interested in is sort of up to medium temperatures. So we like to produce steam. We can go into food and beverage factories that are cooking the meals. So, and the bit, just to give you a scale, it's about 40% of all industrial heat is under 200 degrees Celsius. And the reason that's interesting is if you took every car in the world off the road, it's about the same amount of carbon emissions. So tackling this has a very, very big impact. And then talking about where we fit in, we produce what we call a storage boiler. And in its simplest form, and I'm not sure if Europeans will probably get me, I'm not sure about Americans, we used to have something called a night storage heater in England, which was something you could heat up at night. It was insulated, and then it heated your house during the day. And it was built when nuclear was strong, and they were rolled out a lot. What we built is a giant night storage heater in a vacuum flask. So it's really simple technology in a lot of ways, but actually making it affordable and making it work at scale, it's like most things, has its challenges. But fundamentally, we take cheap off-peak electricity, we convert it to heat, we store the heat when you need it, and then we can produce steam normally for the factory on demand to match their processes.
Some older homes used to have those water-based heat boilers.
And then the bit probably that, just to talk about how we store the heat. So rather than using bricks, we make a material from rock and aluminium. So in that we take hot rocks and we melt scrap aluminium, we pour it over the rocks and it runs through all the holes between the rocks, and we then let it set into a solid block. And I sort of describe it as a bit like conductive concrete, in that the aluminium has 100 times more conductivity than rock. And what it does is it allows you to build large blocks weighing tons that have very, very good conductivity, but they're also quite strong. And we make a mixture of aluminium and rocks because the rocks are cheap. They don't cost very much. We use volcanic rocks, and the aluminium, therefore, it reduces the price of the scrap aluminium further. And that's basically the core of our heat storage technology, because it's very, very easy to get heat into this material and it's very easy to get heat out. And those are normally two of the big challenges when you look at thermal storage, which is you want materials that can actually, a lot of the cost is not in the material itself, but it's how do you get the heat in cheaply and how do you get it out cheaply.
That was my next question, actually. What are the key advantages of using volcanic rock and recycled aluminum in your storage system?
So because the conductivity of the aluminium is high enough, we can do two things. We can embed conventional electric heating elements into the material directly. So when we cast the block, we also cast it with the electric elements in, and you can then just run electricity through them and you heat the material directly. We also put a steel coil within each block. They're actually shaped like wedges. Um, and this is how we get the heat out. So the second difference is we can create steam directly by squirting water into this coil. It's encased within a wedge, which might be at 500 Celsius, so between 250 and 500 Celsius is the normal operating range. And it flashes to steam. And by varying the amount of water, a bit like you vary the throttle on your car for the amount of petrol, by varying the amount of water, we control how much heat we take out. And so what we ended up with is, I would say, our storage material it's not the cheapest, by no worries about that, it's not the cheapest, but everything else around it is the cheapest. So we have the cheapest way of getting electricity in, we have the cheapest way of getting the heat out, and then the vacuum insulation, which we developed when we built smaller units, that has a very interesting scaling effect. So traditionally, when you want to build thermal anything, whether it's power plants or stores, going bigger is better, because as you build a bigger tank, the surface area to volume works in your favor, and therefore the losses become less important. So that's, to my mind, vertical scaling. What you also see as horizontal scaling is where you just make lots of things. So we've seen that with PV, we've seen that with batteries. So they have very, very good horizontal scaling. Thermal plant tends to like vertical scaling. What the insulation does is it allows us to build a relatively small unit, by small, 3 meters diameter, 10 meters tall, that's at really quite high temperatures, but that doesn't suffer heat loss. So we sidestep this surface area to volume relationship, which means we can then fit into the horizontal scaling by just building lots of them. And when I think you look at some of our competitor solutions, I describe them as building projects because they're on site for 6 months or 9 months and they need to put up a big building. And our plan is to be on and off site within a week. That is our long-term goal. And so that's, I said, so probably that's the one other differentiator is the ability to run down the horizontal scaling, which is, to my mind, the only way you can grow rapidly if you want to meet the requirements we need for industrial decarbonisation.
So, how small an application can you apply it to?
So if you have a factory, I'll probably give you some numbers. If you have a factory where you have I'll give a European, your energy bill is, let's say, £2 million, so maybe $3 million a year, your annual energy bill. That is the sort of size we want to start having a conversation with you. If it's much less than that, it's unlikely that you use enough energy to justify us putting a system in. There are certain fixed costs with putting a system in, much like anything. So I generally think that's a reasonably good number. I can also tell people in terms of energy and electricity usage per annum. The other way to look at it is, I say to people, if you're looking at putting solar with our system, say where you might build a larger solar field than your factory needs for electricity, but where we're also now tackling some of the heat, you need sort of sites where they want to use at least 3 megawatts of solar as the minimum. And, the number would be 10 megawatts of solar. So it helps to give people a sort of feel for scale. So when somebody says, I run a small microbrewery, we would politely decline. But if they happen to be one of the big brewers and it's a large factory, I can guarantee you they will use enough energy to be interesting for us.
Thank you. You've emphasized the importance of integrating solar PV with your storage boilers. What are the economic and environmental benefits of this integration? And you've answered it a little bit.
There are two reasons we're so keen on solar. The first one is because in sunny parts, so there's a sort of a combination trade-off. If your electricity and gas price is high and you're in a sunny location, it will work. And it won't work for all of your energy uses, but it will work for a much bigger proportion than you might think was possible if you just looked at electricity only. We do this because of what we see in most grids today. There is a particularly European grids where you have a lot of historic charges added onto the price of electricity. That means that the actual price the end user pays is quite decoupled from the price in the wholesale price. So you can have the wholesale price being zero and wind turbines being paid to turn off. At the same time, they're charging you so much more than you might say, if I had electricity at the price of gas, I will use it. I'll always swap. We talk to want to do the right thing. They want to burn less fossil fuels. Nobody's not wanting to do it, but they're going, you want to charge me more for electricity than I pay for gas. At the same time, you're paying someone to turn off. So we see that there are structures are not really yet evolved to cope with large amounts of renewables, and the price signals aren't there. So this then means it requires regulatory change and potentially political will. We don't know when that will happen. So we're very clear, which is the moment it changes, we are ready, and we see the grid as being a very good market. But the beautiful thing about behind the meter solar is there are no charges. So it's a very simple, it doesn't matter what the regulatory situation is. You're paying your capex up front. You know what the price of your energy is going to be for 20, 25 years. And the payback is very, very, if you get the right level of decarbonization. So from our perspective, it doesn't require regulatory change. We're seeing things move quite quickly. And I would suspect in 2 or 3 years' time, we would be pushing both grid solutions and solar behind the meter. But today, I know very well that even if I don't know what the market structure is, if they put solar in and they have the right energy demand, and we know the price they pay for gas and electricity, you can give them a pretty clear view as to whether they should do this or not.
How does this solution compare to traditional fossil fuel-based heating methods in terms of cost and efficiency?
It depends again on the market. So I would say in parts of the US where you have very, very cost natural gas, economics are challenging, particularly if the Inflation Reduction Act is repealed. In certain other markets, like European markets, where the cost of gas is quite high, and it can be very good. So the sort of switchover point, which I sort of use as a rough proxy, which is if the levelized cost of electricity from the PV is the same as the gas price that the customer is paying, so not the wholesale, but the same as the gas price customer is paying, it works. And if its levelized cost is below the gas price, it works really well. So there's very much a sort of tipping point. The actual electricity price can have an impact as well. But if you're talking the sort of sites we look at, they might use 5 times as much energy in gas as they use in electricity. So if you can make inroads into gas, it makes a huge difference to how big a solar farm you build.
So there is a steel plant going up in California that's going to use solar, on-site solar. Uh, is that something that you might be able to help?
No, it's the temperatures. The temperatures are wrong.
It's too high.
So we're very much brewing, distilling, any sort of food production,
Food production.
making paper or cardboard, making pharmaceuticals. These are the big industries that we're interested in. But as soon as it goes to that temperature, it's not our area at all.
And there's a lot happening in the global south where, because solar has become so down to 1 cent in some places, that factories and industries are putting up their own solar next to their plant.
Everywhere. And they're putting in, I see people putting in electric batteries. And then the next logical step is to start tackling heat. And I'm probably supposed to say one of the reasons we call our system a storage boiler, rather, is that it works very happily as an electric boiler. It's got storage built into it, but it works perfectly well as an electric boiler because if you can use the heat in real time, you don't actually need to store it. So you can sort of see how you effectively build bigger solar and you start to use some of the electricity as to your factory electric load. Some maybe goes into a battery if you've done that. You can then put some to getting rid of your heat load in real time. And then anything left over, which is the lowest value bit, we put into storage, and that can then run the heat load at night or in the morning.
How long can you store the solar energy as heat?
Months. But if you store it for months, you shouldn't have put our unit in. So most applications, the longest we would see is 1 or 2 days. where you might lose 5 to 8% if it's really hot. And that would be a factory that's maybe working 5 or 6 days a week and it's not operating on the Sunday or the Saturday. But fundamentally, if you put our system in, we want you to be running ideally 7 days a week, but 6 or 5 can work in certain cases.
Industrial heat is a significant contributor to global emissions. What are the biggest challenges in decarbonizing this sector, and how does Caldera address them?
So the biggest one is price. In most markets, electricity is significantly more expensive than natural gas or coal, and it depends upon the market you're in, but coal can be, very large scale. So we see the price that you pay for electricity has a very big impact. I would say companies are becoming much more sensitive to the amount of carbon they emit. We're making products. So consumer-facing industries tend to be, I think, ahead in this regard. But we would see what we want is when there is surplus generation, which occurring in more and more markets, and you would expect it to be a natural part of how we decarbonize the grid. So it's in the real world, you want to build renewables, then you start not being able to use it all, and then you maybe add some more electric demand. So you add some electric vehicles and you raise this, and you maybe add some flexible demand, which is where we come in. And then you're starting to use the renewables, but now you've built some more. And this is why it's a transition, which is you need to build the demand and the generation hand in hand. And people shouldn't be afraid that we're throwing energy away. We used everything that was generated by renewables. We probably have built the wrong system and we're wasting money. So it's a journey you're going on. But I don't believe any business can go to their board and say, we want to decarbonize and go from gas to green electricity, but we're going to pay 3 times as much. That just isn't reasonable. If they can have a 5-year payback, 6-year payback, that they'll go for it without a shadow of doubt. But to me, at the moment, the issue is they look and go, well, our electricity price is this. It doesn't add up.
You've touched on this a little bit, but I'll just ask that anyway so you can give the full breadth. What industries are best positioned to benefit from your technology, and what are their specific needs?
So I'd say food and beverage by far is where we have the most inquiries, but steam is used as a way of transmitting heat around sites. It's been very popular for, over 100 years, in that you can have one central boiler house generating steam and it pumps itself around a big network. So you find it on hospitals, you'll find it on old army bases, you'll find it in government buildings. In the States, it's often used for heating at low pressure within apartment blocks, but it's also used within factories very commonly. So the way I would describe it is, well, we are focused very much on sort of food and beverage. Like electricity, if I generate electricity at a certain voltage, it doesn't really matter what the industry is. And with steam, it's very similar. So we generate steam up to 16 bar of pressure, which covers pretty much all the normal applications. And consequently, when we plug into a steam network, it doesn't particularly matter what the industry is. It's very much the same technology each time.
You have a lot of patents in thermal energy storage. How does this technology play a role in grid stabilization?
So I'll probably give the UK as an example because I can explain it more easily. We're building a lot of offshore wind at the moment, and the latest forecasts are within 2 years, maybe 2.5 years, we'll have 1,000 hours a year when there's too much electricity being generated, and we have to curtail it. We have to basically pay them to turn down. At the same time, you've got too much wind being generated. The wholesale price of electricity should drop to close to zero. Now, in an ideal world, you would do things like turn off all of your gas power plants. But it's quite difficult to run a grid with all the gas power plants turned off. So there are 2 things that happen. When you start to switch off all your power plants, the inertia of the grid drops. So the inertia is like how many big spinning things do you have plugged into the grid, like a power plant. And you also then end up running the part load, which is a very inefficient way of running a combined cycle gas turbine. So you turn them right down, and so at the same time you're paying them to run, you're paying somebody else to turn off that could replace it. But you want the gas plant because it will turn up at relatively short notice to give you more power, and it's quite reliable. So we end up with a situation where the grid has got low inertia, where we're running some plant inefficiently because we need them for management. Now, at the same time, industry using a lot of heat, and in the UK, something like 6 gigawatts. And some of that has quite big grid connections for various reasons. So there's an opportunity to effectively let industry use the electricity when you're paying someone to turn off. So let's say 2 gigawatts of heat. And if you put thermal storage with it, you say to the grid, you know, they can turn off their boilers because they've got 4 or 5 hours of storage. You can say to the grid operator, well, you can flick you in exchange for allowing us to buy electricity at low price. You can flick us on and off like a power station. And 2 gigawatts of demand you can flick off at a second's notice. And you can with electric heating, it doesn't impact it, is a bit like a power station, a 2 gigawatt power station you can turn up in a second. So you end up with the scenario. And the beautiful thing about hybridization, as I describe it, where you are taking what would be a gas boiler and running electric heating through, is it doesn't get full. It's like using the 2 gigawatts 24 hours a day. I can keep putting 2 gigawatts electricity in. It's not like a battery where after 4 hours it's now full, or 6 hours. It's like full and I'm stuck. It's like thing can keep taking it in real time. So industrial heat is like, and because it's fuel switching rather than changing the process, businesses will accept it. One of the things I'm still fairly convinced about is that people don't like to change how they run their processes. So no one cares if you switch between gas and electricity, but if you tell them you can't run it in a certain way, they want to do it. It's quite more resistance. So to me, industrial heat has this ability to help support the transition, because not only am I buying 2 gigawatts of electricity now from these wind turbines that don't have to turn off, the grid doesn't have to run the power station at 60% load, just paying them to burn gas when they don't need to. And also some very rapid response power plant, which is demand that you can flick off at a moment's notice. So to me, when you look at sort of counterfactuals of what else you might do, there aren't very many that can meet this, and they all seem to me to be more expensive. Because if you had a battery, for example, you want to be charging the battery when the price of electricity is zero. You don't want to be, so it's like the battery wants to be empty when this happens because they want to fill up with electricity. So that's not the sort of solution you'd want for this. So I think industrial heat has this enabling ability within the transition to help support as we grow more wind and solar. We can convert more heat to hybridization. And to me, hybridization is very powerful, because the last thing you want is these factories running on electricity in the depths of winter when there's no wind and there's no sunshine.
You've highlighted the rapid decline in solar costs. How is this impacting the industrial energy landscape, and what opportunities does that create?
So I would be amazed if there is a single factory actually in the world that hasn't looked at putting solar on their roof, or starting to see now about, if they're a big energy user, getting a field nearby, or even having a developer get hold of a field nearby and approach them about would they like to take the electricity. So to me, it's very rapidly. I think and the prices of installation have absolutely plummeted. So I think most factories are aware, but the normal limitations are the grid. And actually, the biggest limitation is the grid. And it's sort of how much electricity you can use. So we're seeing grids congested everywhere there's a large amount of renewables. They're saying no export. So suddenly, if you're a sort of electric and heat user and you're just thinking about electricity, which most solar companies just think in terms of electricity, well, I can put a certain amount on, maybe on the roof, and that's sort of the limit. No, we turn up and we go, but look, you've got a giant boiler house. You've got these 5 massive boilers that are all running 24 hours a day. You need to take the farmers the next 5 fields. That's the amount of solar you need, and we don't need to export any. We can consume it all on site. So I tend to think with industry is that everyone's very aware of solar for electricity. People aren't considering solar for heat, and they also underestimate the scale of how much solar you can install to meet these sort of much bigger heat demands.
How can industries leverage this cost reduction to accelerate their decarbonization efforts?
So I think it depends on how they're looking. I mean, so many different approaches within industry, but putting a large solar farm, I mean, if you assume it's 4 acres per megawatt, if you put a 10 megawatt solar farm next to a factory, you need 40 acres, probably within half a kilometer to half a mile, that sort of distance. So normally there are planning constraints, there are regulatory constraints. And the other side of the coin is that most companies, you potentially want to have a financial player in there that can offer a PPA to the company over a 10 or 20 period. It's the most, so on the solar side, the cost is very low at the center kilowatt hour you mentioned, if you can write it off over 20 years. If you write it off over 5 years, it's actually quite an expensive investment. So to our mind, we see the solar elements being ideally funded by PPA providers, so infrastructure players. On the equipment, when it's on site, our experience is that the companies want to own anything that's involved with their process. So they don't mind a cable coming in and paying for each unit of electricity. They do mind somebody else having control of their boilers. So what we see is it's almost a PPA for the solar, and then it's a purchase of the assets.
You've spoken about the need for flexible to manage increasing renewable curtailment. What role does industrial heat play in providing this flexibility?
So it was sort of, as I captured it earlier, it's large, and because of the size of it, and because most of it is on natural gas, it's actually relatively easy change for people to switch between two heating modes. Um, I think electric vehicles can provide a lot of flexibility. I'm less convinced about doing things like controlling hot water cylinders in people's homes, just because of the number of devices you need to control. But I think generally it's the point about heat loads for industry is they're just very, very, can use the same amount of energy as, 10,000 homes, that sort of scale.
How can grid operators and policymakers incentivize industries to adapt flexible demand strategies?
So they need, to my mind, when there is surplus generation, price of electricity needs to fall to there's flexible users. I can imagine you could create, so on a generation side on solar, they're already creating flexible grid connections so that if the grid is too busy, they can get turned off or turned down by the grid operator. You want the same thing to happen on the demand side. So you've got your normal demand for the factory, and then you've got a second grid connection, which is your demand for your heating, that the grid can allow you to turn on and off. But when it turns off, you need to be able to get electricity that's cheaper than gas. It needs to save you money. And as long as that is happening, people will do this. I personally think there's more value because you actually, control point of view, as I described, electric heating is something you can switch on and off very, very, and without having any impact on the life of the equipment. And so to me, that's an obvious win, which is the grid has to have less assets it can turn up if it can turn demand off, has exactly the same effect.
Hybridization of industrial heat, switching between gas and electricity, seems like a practical short term solution. What are the long term implications of this approach?
So I sometimes go, I'll be really honest, I don't care. As in, it's a transition. We don't know what the grid is going to look like in 20 years' time or 30 years' time. 10 years ago, I could not buy I could maybe buy a very expensive, impractical electric vehicle. Today, half of all vehicles sold in China are electric. So my frustration is that it's, to take the UK as a good example, we're very proud that we decarbonised a large proportion of our electricity grid. But if you look at heating, transport, we're 15%. And to me, the focus and the mission has to be on getting to 50%. And at 50%, I'll start to worry about the last bit. But it's a very much a transition. And as I described it earlier, you need to build renewable generation, you need to build design in step together. And we should therefore do the things that are obvious now because we know there are going to be better technologies available in 10 or 15 years' time. And I also feel that, but I want to have a fully electric solution. You're like, but it's really expensive. We don't have the money. To my mind, as a society, we can't waste money on things when, and a good example would be, we keep knocking down power stations that I think we're going to have to rebuild. And when we rebuild them, we're taking capital that could have built another wind farm or a solar farm. We're now having to spend it on replacing the power station that we should not have allowed to be demolished. So we have to look after our capital and we can't afford to waste it. So to me, when I look at hybridization, it's the cheapest, fastest, easiest way to get to the next step. And to some extent, I know that in 10 years' time, you're going to have a different set of answers because we will have different technologies available.
How can we ensure a smooth transition to fully renewable power industrial heat?
Whenever heat pumps so I'll probably drop a heat pumps in now because that's one of my favorite. Heat pumps work very, very well at low temperatures. I would say up to 100 Celsius. You've got heat pumps also working well if there is a supply of hot waste heat, and be a good example where you're evaporating something and condensing it. You have a supply of heat on the condenser that's not far away from the evaporator. So there are what we see is like fitting like heat pumps is really very sensible, but they're often quite hard to retrofit. So what I do believe is that as we build more and more new factories, we will see integrated solutions where they've been thought of from day one and the heat pump is built in. and hence the energy demand is dropped by a factor of 3 or 4. And we've recently taken an investment from a large German company, strategic company that works very much in this space. And their interest, they're called, I'm going to plug it, Care Group, but their interest is because they see our technology working alongside heat pumps, where the heat pumps do the base load and we do rapid power changes. So we're not moving large amounts of energy, we're moving large amounts of power, and you let the heat pump be the workhorse. So you end up with a solution where it's a combination of heat pumps and storage boilers, and you actually get a very good overall COP, and it becomes effectively economic if the gas to electricity price is about 3. So when I go forwards, I think lots of factories, as they get replaced, upgraded, rebuilt, their energy demands will drop because heat pumps will become an integral part of the process. What I see today is lots of older factories where we can help them at least for part of the journey. But if you want to get them the full way, often it is a case of fitting things like heat pumps. And if they haven't built them with the bits like you end up with the waste heat a mile from where you want it, it's actually very hard to retrofit that. So those solutions I'm not sure about. And then I'll probably make a last comment about decarbonization in general, which is the first, modeled it, the first sort of 70, 80% is affordable. The last 20% can be very, very with current technologies. But this is why I say we don't need to worry about this. It's like that's the bit that we know how to do. And let's assume that the solutions will emerge over the next decade or two.
You have experience with pumped heat electricity storage, PHES. How does that technology compare to your current work at Caldera?
So we developed a system that similar temperature ranges. You took electricity and you used the heat pump to convert it to heat at 500 degrees centigrade and cold at minus 160. So we don't do the cold. And you could reverse the process to get electricity back. What I would say is batteries have completely won. They have higher efficiency and they have lower cost. When we started the project, that was not the case at all. So we're talking about 2008. But no, batteries have completely won, and I think is a better technology. It's no there's no moving parts. It's not a mechanical system. So I no time on it. Whereas what we have is just the thermal storage bit, where we also have no moving parts. And on a cost basis, we are competitive and significantly cheaper than batteries, which is why you'd fit us in your factory. So if you can store electricity for the same amount as you can store it as heat, then you're always going to choose to store it as electricity.
What policy changes are needed to facilitate the wider adoption of thermal energy storage and decarbonized industrial heat?
So generally, it's this it's access to low cost electricity when the grid has a surplus is the policy change you would look for. You don't want to have to pay capacity charges for these sort of connections. It would be nice to have some form of government support, but I'm always quite nervous of industries that I describe it as you can get addicted to having subsidies and it doesn't make you do the work of driving the cost out. And fundamentally, I believe that everybody should stand on their own 2 feet. So I think a small amount of support at the right stage is very helpful for allowing you to get critical mass, but there has to be a plan that if it is granted, it's removed, because in the long run, it just stops people being competitive and actually facing where they need to get their product.
How can we overcome regulatory barriers and create a more supportive environment for these technologies?
I personally think in the UK, pressure will come when we are curtailing huge amounts of offshore wind. So to me, it's because we in the UK and much of Europe, we pay what's called a contract for difference. So we've agreed that we'll pay them, let's say, 5 cents a kilowatt hour. If the price is 0, they still get 6 cents a kilowatt hour. If it's higher, they still get 6. But when you curtail them, it means we still pay them. And the number will get very large very quickly. And politically, I think that is very damaging. I think it's also annoying because there are so many people that would be using that electricity if they were offered it at those times at the right price. So I think that will drive it. But generally, regulatory change is very slow and it's very complicated. So it's one of these ones where I think there needs to be some pain suffered before anything happens quickly.
Yeah, but I think in UK, the smart grid and smart use of energy is probably moving ahead much faster than in other places.
You know, many European countries also moving very rapidly. The Netherlands has a very congested grid and it's starting to effectively implement for industry and industrial heat sort of separate pricing policies. So I think it is coming everywhere in Europe, some earlier than some later, but I wouldn't want to be the one to call when it happens, in which country.
That's fair enough. What are the most promising innovations in thermal energy storage and industrial heat decarbonization?
Well, obviously, I think we are one of them. So, but taking aside heat pumps and high temperature heat pumps, really key, and moving into higher temperatures still. I also see high temperature electric heating as very challenging. And so there are some really interesting, if it can make a high temperature heater that works and lasts, that's affordable and lasts for a long period of time, that will particularly open up markets like cement production, where at the moment it's quite difficult to calcine cement with electric heating. I know one company that's doing some really interesting trials with a plasma heater, but going above that, making a lot of ceramics and steel making would be the ultimate.
How can we accelerate the development and deployment of these technologies?
So we are it's a difficult one. We look for companies that are, I would say, have a strong desire to decarbonize. Often they're larger corporations and maybe one or two of their factories they've picked as, think they have to see a business case. And I come back to it. I think regardless of how much, the manager or the plant manager likes the solution, they have to go to the finance manager and they have to show some form of payback, to make financial sense. So we do see relatively niche applications where we can make a big saving just because of local circumstances or local rules. But I think to get to the large case of there's 1,000 hours of cheap electricity, if you want to use it, if you install the system, we're not there yet. So I think it is all moving in the right direction. I think the volatility around pricing of gas and electricity it's focused people's minds on the cost of heat, but I think it's also created, I would say, the current world. I'm not sure how confident people feel about investing capital.
What are the biggest challenges in scaling up these solutions to meet the growing demand for sustainable industrial heat?
So for ourselves, is very much on, let's call it our wedge production is our limitation. Everything else we can effectively our business model is to outsource it. So our vacuum covers can be made by people that can make steel tanks. And the basis we have a power supply coming in and we have a heat exchanger to generate steam on the customer side. So we have our own little roadmap where we roll out what I say is wedge production, and we have a confident that we can grow it to meet demand. I often say to people, if you can give us 2 years notice, we can build pretty much any amount of capacity. But we're really clear, you want that sort of 2 years notice. If you come to me and say, I want something this amount in 1 year's time, if it's not within our plan, we're not going to be able to do it. So I personally don't see the supply being the constraint. I think a lot of it is actually about market will and market economics. And, for the world, gas is extremely, about solar being 1 cent a kilowatt hour. There's a lot of gas in the world at 1 cent a kilowatt hour. So those are the sort of markets where, unless there's a change of policy, I don't see them starting to decarbonize.
How can we ensure that these technologies are accessible and affordable for industries of all sizes?
Deployment and massive focus on cost reduction, no different to any technology.
For industries looking to decarbonize their heat processes, what practical advice do you have for them?
So practical advice for them would be there's a surprising amount that can be done. And often, as I said, I find one of the things that we come across is people have looked at, say, solar PV and said, well, we've put it on the roof and the grid operator has said we can't have any more and we can't export. And I think the scale, people don't always think about the scale of the heat usage. So if you are a big industrial heat user, when you build very large solar farms, the cost drops very, very, potentially a third of the cost of putting it on the roof. So part of why we like to go large is that not only does it suit our system, but solar gets much when you can start to deploy, tens of megawatts upwards, because it's same team, they're just on site for every week, they can deploy a certain amount of solar. It's a very cost effective way of doing it. So I generally think is people don't think in the right scale as to how much you could actually fit with their factory.
Yeah, they're starting to deploy robots for installing large scale solar PV plants.
Yes, and I mean, in context, the numbers I'm hearing from sort of outside Europe, but where it's being deployed in companies going to put solar in is something like $350 a kilowatt installed. That's everything.
Oh.
It's the racking, the solar, the transformers. It's really.
How can they stay informed and engaged in the rapidly evolving clean energy landscape?
And do you mean this for the customers or for, I mean, try and stay on top of it, but it is moving very, very across the board. And to my mind, you have to watch what's happening in China. They, I think, deployed something like 55% of all the solar PV in the world that was deployed last year. They are doing batteries, they're doing electrification of transport, they're putting in wind. And I see it to a large extent as being done as a strategic intent to reduce the amount of fuel they have to import, particularly coal and oil. So to me, you have to watch what's happening in China. And I think you have to be very honest about how fast it's moving, how low the costs are going, because it's easy to go, oh, we'll be cheaper than, why, but it's what they're doing. And so to me, I just think watch China. At the moment, it's really a shame, but I think they are taking the lead in this area and are moving at a pace that's very hard to achieve in Europe.
Are you doing anything in China?
No, we're not doing anything in China. It's an almost impossible market for a UK company. The idea that we could go to China, sell our product there, it's just not viable. Whether there might be something to be done in the future, yes, absolutely. But I don't believe that Western companies can go into like China, and I just don't think it's possible.
Maybe a partnership or something.
Exactly. But I think
knowledge transfer or some kind of.
it's very interesting. So from our perspective, China is 50% of all the industrial heat in the world. So China alone is the same as everything else. And I have a sort of a lovely vision that, again, while they have grid issues, you can imagine, for solar being connected up, not to the grid, but just to provide heat. So it's also a way of building massive solar farms without any grid constraint at all, because you don't bother to connect them to the grid. You're literally just saying solar to heat. So those sort of things, and I think you'd be much faster to deploy in China. So yes, it is, but it's also been, fundamentally a commercial company, and I would say it's a difficult one to navigate. So yes, we're interested, but I think there are far more tales of failure from people trying to partner than success.
Well, James, this has been an incredibly insightful conversation. Your expertise in thermal energy storage and your vision for decarbonization of industrial heat are truly inspiring. Thank you for sharing your knowledge with us.
And Ali, thank you very much for having me on CleanTitans. I've really enjoyed it. So thank you very much indeed.
My pleasure. And to our viewers, thank you for joining us on CleanTitans. Please subscribe and follow us for more inspiring stories and insights into the clean energy revolution. Until next time, stay innovative and keep decarbonizing. And if you have any questions, please ask in the comments and we will get you the answers. And please tell your friends about us. Thank you.